Okay, two more Pythagorean theorem problems. Take a moment and read through problem 11. So let's see. I have one airplane flying south, another one flying west, and I want to figure out the rate of change of the distance between the two planes. Well, as for a picture, I know this is going to look a little bad, but just go with me on this. I'm going to say the plane flying south is going to look like this, and the plane flying west is going to look like this. No, the plane flying south is not going into the ground, but it's going to look something like this. And there's my airport over there. And I want to deal with the changing distance between the planes. As for labeling the sides, I kind of don't want to use A, B, and C only because A and B kind of represent some other things and I don't want it to get confusing. So I'm going to say X there, Y there, and Z there. All three of these sides of the triangle are changing, so my equation, x squared plus y squared equals z squared, will not have any constants plugged in for x, y, or z. Now, dx dt. The plane that's flying west, actually both planes, are flying at a rate of 520 miles per hour. If this plane's going west, 520 miles per hour or negative 520 miles per hour. And what we really need to think about is what's happening to this side of the triangle. If that side is increasing, I want my dx dt to be positive, and if this side is decreasing, I want it to be negative. So what? Positive or negative? I think it should be negative. dy dt. Figure out if that is positive or negative. I think that one's also going to be negative 520 miles per hour. Part 2, I want to find the rate of change. You know what? You go do part 2. You can fill that stuff in. I want to find dz dt. In particular, when x is, okay, plane A is 50 miles from the airport, so when, no, hold on. Plane A is 50 miles from the airport, so when y equals 50 miles, and when x equals 120 miles, go get your derivative. Edpuzzle will pause. 2x dx dt. Remember, everything's a function of t rather than a function of x, so anything, including that x, will have a d something dt afterwards. Should look like that. I'm going to fill in my negative 520s. And negative 1040x minus 1040y equals 2z dz dt. I suppose if I was being smart, I could have divided everything by 2 and not have such big numbers, but whatever. Go do your part 4 and see if you can finish this problem off and send in your answer when you're done. So I know my x is 120, I know my y is 50. I could use Pythagorean theorem, but it's also a 5, 12, 13 right triangle, so that'll work over there. I'm going to fill in my values. Negative 1040 times 120 minus 1040 times 50 equals 2 times 130 dz dt. Negative 176,800 equals 2 times 130 equals 260 dz dt. Divide, and even though they're big, I think it's going to be nice, if I remember correctly. Yep, negative 680 miles per hour. The rate of change of this distance is negative 680 miles per hour, it's shrinking. Or we could say it is decreasing at a rate of 680 miles per hour. I guess I could just factor in the negative sign by using the word decreasing. So either this or decreasing at a rate of 680 miles per hour. One more. Take a moment, read through problem number 12. Okay, so let's see. Here's the depot. One convoy is going east, one convoy is going north. I'm going to say this is convoy A, this is convoy B. There's the distance between them. Again, I'm going to go with an X, a Y, and a Z. All sides are changing, so X squared plus Y squared equals Z squared. See if you can do the rest of your part 1 and then part 2. So I know dx dt equals 40 miles per hour. I know my dy dt equals 30 miles per hour. Part 2, I want to find dz dt. And I want to do this when, let's see. Oh, this is kind of strange. I don't know an x, y, z, but I know some t's. When t equals 6 minutes, and when t equals 30 minutes. That's going to be a little different, but whatever. Do your part 3. Find your derivative, plug in your dx dt, dy dt, and then we'll deal with part 4 together. (2x dx dt) plus 2y dy dt equals 2z dz dt. 40, 30. So 80x plus 60y equals 2z dz dt. Now, when t equals 6 minutes, well, I know that this truck is moving at 40 miles per hour, and this truck is moving at 30 miles per hour, and those are constant rates, so I can figure out how far the truck has gone. 6 minutes, by the way, is just 6 over 60, 1/10 of an hour. So truck A will have gone, it's going at a rate of 40 miles per hour. 40 miles per hour for 1/10 of an hour means it's gone 4 miles. Truck B is going 30 miles per hour, again has traveled at for 1/10 of an hour. We're getting 3 miles. So 4, 3, oh, this is easy. 3, 4, 5 right triangle. My x is 3, wait, hold on, that's not right. My x is 4, my y is 3, my z is 5. Plug in, and we've got 80 times 4 plus 60 times 3 equals 2 times, what is it, 2 times 5 dz dt. This is looking like 500 equals 10 dz dt. So dz dt is going to equal 50 miles per hour. See if you can go through a similar analysis when t equals 30 minutes, and you're going to send that answer into Edpuzzle. So 30 minutes is a half of an hour. truck A that was going at 40 miles per hour has gone 40 times a half, has gone 20 miles, and that's an X value. Truck B going 30 miles per hour, 30 times a half is 15 miles, and that's a Y value. So 80 times 20 plus 60 times 15 equals 2 to, oh, I guess I should have solved my triangle. My X is 20, my Y is 15 by Pythagorean theorem, or by a multiple of a 3, 4, 5, that's 25. I think I'm not going to bother showing the rest of the work. You can handle doing that, but you're actually going to get the same answer we got for 6 minutes, which is the case because all those sides are changing at a constant rate. So Z is also then changing at a constant rate in this particular problem.